we're going to increase our understanding of atoms by looking at atomic structure, what makes up the atom, and we can do it with simple materials. And here we've got beans. But before we start, list what you already know about atoms and complete at least 5 bullet points explaining what you know. And then we'll follow up by discovering how we can develop a more detailed way of representing atoms. So you'll need 2 different types of similar sized beans. Here we've got 2 different colours. The navy beans are white and the black beans are black. And we're going to use a weighing tray, a small dish. You could even just have a square circle of paper instead of that. And we make an assumption that atoms are spheres, but they're more complex than that. We're going to look at the 3 main subatomic particles and try to decide if we can assume they are spherical. So the subatomic particles, protons, neutrons, and electrons, bracketed or kept the protons and neutrons together because they are both present in the nucleus at the centre of the atom. Protons are positively charged, neutrons are neutral, have no charge, and electrons moving, surrounding the nucleus, they are negatively charged. So how do we know how many we've got of each type? The number of protons equals the atomic number of that particular element. Number of neutrons is the atomic mass of that element minus its atomic number. And the number of electrons equals the atomic number of the element, and you'll notice that is the same as protons in a neutral atom. Same number of positive protons as negative electrons. In order to find that information, you'll go to the boxes on a periodic table to get the element's atomic mass and atomic number. And we're going to look at the beginning at something. Here we've got iron, and the atomic number, the lower number in the box that there is 26. That's the number of protons, and jump down, that's the same as the number of electrons. And the number of neutrons is the atomic mass, 56 minus 26, giving 30 neutrons. And so we're going to use, in our key here, the black bean as the proton, so there should be 26 in there. And then to make the nucleus of an iron atom, and the iron 56 isotope with a fixed number of neutrons, here 30, we should have 30 of the white navy beans there. We want to know how many electrons around. If it's iron, it's going to have 26, the same as the atomic number. And we can represent the electrons with WIS in a modelling activity. Electrons arranged in shells in the Bohr model, 2, 8, 8, and then a few more in each shell going out from the nucleus. And there's a diagram there with dots representing electrons. And we can do that with our model by having a piece of paper with the concentric circles for the electron shells already drawn, add the beans to represent the protons and neutrons in the nucleus, and then the rice, fill up the 2 in the inner shell first, then the 8, build it up to get your electron configuration, and you write them down as 2, 8, if there are any enough for 8, and how many are in the 3rd shell. So a few questions coming here, looking at here black beans are protons, how many protons, identify the element. and how many electrons would it have, and what would that element's electron arrangement be in terms of numbers 2, comma, whatever. And read these ones, pause to read the following questions, and this one being asked what isotope it is. So the number of the neutrons, here shown as the white, the navy beans, dictates which of the isotopes it is. You total the number of beans and you write that number after the element's name and a dash. So before you would have had iron dash 56. And question 3 is similar, so pause to complete that one. And indeed, question 5. And then we've got question 6, where we're asking you what isotope it is and to add its electron arrangement. And you could use the paper with the circles and do it with WIS if you need to. So ending up like that, are the atoms going to be spherical in the model that we're producing? We'll develop that further as we study more chemistry. And how does the modelling like this help your understanding of what makes up atoms of different elements? So just jot a couple of things down, what helps and anything that doesn't help. And also to add, what else could you have used other than beans to model protons, neutrons and electrons in atoms of different elements? So thank you for going more deeply into the structure of the atom, and thanks to Miss Denny and her 9th grade chemists.